Sound the alarms, people. Sound the alarms. It's about to get a little bit interesting here because we are going to expose some mathematical lies. I know. All right, so here we go. Addition no longer means to add, and a subtraction sign no longer means to subtract. I know, all those years. Okay, so here's what we're after. Today we're focusing on just the addition side. So all the problems that we're going to see here are adding problems. Now, the rules are the same for addition and subtraction. And what we're going to work off of here, and this is kind of like that algorithm side, if you will. And what I mean by that is, it's like here are your rules. You're going to get to the stage where it just starts to flow. I mean, it's just rapid fire there. Just like if I ask you, 2 plus 7, stuff like that. But it's going to take a little bit of time because you have to relearn how to add and how to subtract. Which, for a lot of you, that's going to be a bad thing. I know. So let's go through it here. Here's your rules. That silence was dramatic pause. Okay, same sign. Okay, same sign. We're going to add and we're going to keep. We'll talk here in a second. All right. Different signs. All right. We're actually going to subtract. All right. And then we're going to keep sign of. And this is where we kind of get a little mathematical here. We can say keep sign of bigger absolute value. All right? So we'll go mathematical here. So we will say, so a bigger absolute value. So like I said, it makes some appearances. We talked absolute value in the previous lessons where we're like, come on, distance from 0, why on earth am I going to use that? Well, this is one of those particular locations. Okay, so first of all, we're talking about same signs or different signs. We're talking about positive and negative. So I'm going to list things out here. Now, for the notes, write it down. For the classwork, it's not a requirement unless, of course, you're getting all these problems wrong. Then that's a technique I'm going to want you to go back to do. So here we go. You can tell if a number is negative or positive just by looking to the left. The very first person you see tells you if it's a positive or a negative number. So look at this 5. Question number 1, 5. If I look to the left, there's no one there. Well, think about all those numbers over the years. If I told you to write a 5 down, you are writing down a positive that's there. So it is a positive 5. Look at the 8. Positive or negative? Well, it is a negative that's there. So we have different signs. So let's follow the rules here. Because we have different signs, we are actually going to subtract. Again, I see the addition sign there. But now that negative numbers have shown up, it's going to change things there. So we are going to subtract. When we do our subtraction sign, our subtraction problem, it's normal subtraction. So bigger number first. So 8 minus 5 gives me a 3. But I have to keep the sign of the bigger absolute value. So absolute value of 5 is 5. Absolute value of negative 8 is 8. So who has the bigger absolute value? Well, the negative 8 does. So I need to keep the negative sign that's there. Now again, this is the algorithm side to it. The goal here is you're not doing all that thinking and analyzing. You're kind of visualizing. You're trying to apply. I got $5. I spent $8. I owe someone $3. Well, there's your negative 3. So we want to get there, but for a lot of us, we're going to need a sequence to get us there to work out. Let's look at question number 2. That first number, the 9, positive or negative? No, it's negative. The 5, look to the left. There's an addition sign. Well, because it's an addition sign, and that's the first sign I see, that tells me it's a positive that's there. Again, different signs. So like the rules say, we're going to subtract. 9 minus 5 is a 4. Again, I'm not doing anything with the negative 9. I'm just doing 9 minus 5. I'm just taking the numbers itself. And again, I got to keep the sign of the bigger absolute value. Or in other words, the bigger number, if you will. 9 is bigger than a 5. So yeah, am I doing the absolute value of negative 9? I am. But if you'd rather just take away the negative signs, and that's kind of what absolute value is, that might speed things up a little bit. So 9 is bigger than 5. The 9 was negative, so I keep my negative symbol that's there. Again, like I said, it slows things down. Things will start to speed up that's there. All right, so I got 3 things going on here, but it is addition and subtraction, so we're just going to go left to right. So negative 5 plus a negative 10. Okay. The 5, look to the left, it's negative. The 10, look to the left. It is negative. Now, you might be saying, whoa, but there's that plus sign there. Right. Remember, we always use the first person we see. And the first person I see there to the left of the 10 is a negative. So, because it's negative, they're both negative, go up to the top there. You can see is when they have the same signs, we add and we keep the sign. So 5 plus 10 is a 15, and it's going to stay a negative. All right? I now have to add 2 onto it. Again, if we can visualize the number line, wow, if I'm at a negative 15 and I add 2, I'm moving to the right 2, I'm at negative 13. That works. Algorithm-wise, you can see the 15 is negative. You can see the 2 is positive. Different signs. 15 minus 2 is 13. Keep the sign of what you have more of. I got more negatives. So that is your negative 13. Again, different ways of looking at it. Question 4. You could just say, hey, they're opposites. Anytime you combine opposites, you always get 0. I'll buy that from you. I can take I'm at negative 6. I move to the right 6 spots. I'm at 0. You can also say, hey, that first number is negative. That second number is positive. Different signs, so let's subtract. 6 minus 6, 0. I'm not worried about positive or negative because it's 0. All right, let's go on to question number 5. 5 plus a negative 7. Okay? We should be seeing that it's a positive 5. We should be seeing it's a negative 7. So they are different signs, so I'm going to subtract. If I subtract 7 minus 5, I get 2. Keep what we have more of. Well, I had more negatives. Or in other words, the absolute value. So, yeah, it's a negative 2. And then bring it on down, plus a negative 2. You'll notice here that we're wrapped in parentheses. You might be thinking is, wait. I thought that a number up against parentheses meant to multiply. Yes, Mr. Elephant, you are correct. That does mean. But I don't have a number up against parentheses. So sometimes we use the parentheses just as a visual. What we don't like as math is to have 2 symbols right up against each other. If I take away the parentheses, do you see how the plus sign and the negative sign are right up against each other? We don't like that in math. So we also bring parentheses out as a way of separating things. So they are both negatives. So because they're the same sign, I'm going to add. 2 plus 2 is 4. And I got to keep the sign. So it's a negative 4. That's there. Let's do one more here. All right. Negative 8 plus a negative 2. First number is negative. Second number is also negative. Remember, you're just looking to the left. Same sign, so we're going to add. And we're going to keep the sign. So it does become a negative 10. That's there. So as I scan down here, we got a few more that's here. All right. Pattern. Man, there's lots of patterns there. That's kind of a general question that's there. The adding the integers, when we get into lesson 7, we're going to kind of fill this out a little bit. So now that we've started practicing, we started to make some generalizations as well. So with all that being said, we're done for tonight here, people. But like I said, don't trust that addition symbol. Don't trust that subtraction symbol. Everything is based off of, do you have the same signs or do you have different signs? We'll get through it there, people. Scary, but we'll get through it.